So in American medical innovation, and especially in Boston, the two people that are going to come to the stage here are just so special and so much for all of the rest of us to learn that they can share with us. And I think they haven't done anything like this before. So it's kind of a cool thing, and I'd like to believe we're all in for a very, very special evening. And so to kick it off, Dr. Paul Anderson, our Chief Academic Officer, is going to introduce both of them. But stay tuned, and I hope everyone stays in their seats over this entire session.
This is dangerous back here. Thank you, Chris. And really, what a day. I mean, we've gotten amazing science, we've gotten clinical trials, we've gotten finance, we've got politics, and now the icing on top of the cake. This is amazing. I'm really looking forward to this. I get the good fortune to introduce two people whose respective work has touched countless lives by bringing transformative change to their fields of scientific endeavor. I did meet with the Wellman group, and they told me I should try to pull them out a little bit, get them to come out of their shells a little bit during this talk. So if you can just try to do that, guys, that would be great. Dr. Robert Langer is one of just 9 institute professors at MIT. He's a pioneer in fields of controlled drug delivery systems and tissue engineering, improving the ability to treat conditions from cancer to diabetes to birth defects. The Langer Lab at MIT is the largest biomedical engineering laboratory in the world. He's authored these numbers are kind of crazy. He's authored over 1,600 scientific papers. I don't know how you do that. And he's also one of the most frequently cited engineers in history. He has over 1,400 patents and patent applications. And he's been involved in founding over 40 biotech companies, including household names like Moderna, who, by the way, saved us from a global pandemic recently. And he'll be joined on the stage by Rox Anderson, one of our own. Dr. Anderson is the Lancer Endowed Chair of Dermatology at Mass General. He's the director of the Wellman Center for Photomedicine, the largest center in this field, and a professor of dermatology at Harvard Medical School. Among his inventions are non-scarring laser treatments for dermatologic care and a non-invasive treatment for permanent loss of fat. He's also an inventor on more than 60 patents and has authored over 300 scientific papers and books and has established charitable medical treatment facilities in several countries. In 2022, he was inducted into the National Inventors Hall of Fame. I'm looking forward to, and you should look forward to, really an enlightening conversation between two visionaries, two luminaries, and this is really going to be a lot of fun. So Rox and Bob.
Can you hear us?
Good.
Good.
You can, okay, good.
This was billed as a fireside chat. Chris, where is the fire? I hope the fire is somehow here, but also here.
Well, I think it's definitely in here.
Yeah, and I have to say, this is probably the lowest carbon fireside chat I've ever participated in. Thank you.
Well, thanks. So you know, Rox, maybe I'll start. You know, I think was mentioned in the introduction. You know, you've mentioned just a couple of your amazing inventions, like laser hair removal and actually making new ways of body sculpting using cold rather than heat and things like that. I'd love to hear what your thoughts are on the latest things that you're excited about and the next inventions that you think would be coming.
I'm going to ask you the same question in a moment. Yeah, I'm actually very excited by, there was a talk given here by Lilith Garibian, who's started as a postdoc in my lab about pain control. So when we discovered 20 years ago that cells that have a high lipid content are exquisitely sensitive to cold tissue cooling, because the lipids will crystallize and it disrupts metabolism, but also can kill the cell. It turns out that the myelin sheath around nerves has 70% lipid, and we are right on the cusp of being able to treat chronic pain by injecting ice. So here we are having after dinner drinks. Of course, this was invented in a bar when you have you have a daiquiri. It's basically flowable ice, and the ability to inject that. So physicians are good at doing nerve blocks, but when you do it with ice, you end up with a 3-month long duration of the nerve block. So I'm very excited about that. We're studying the effects on the nervous system, the peripheral nervous system, what's going on in dorsal root ganglion cells and so forth. But what's really exciting is just that it's really going to help people. So you have about 30% of Americans living in some version of chronic pain.
Yeah, I want to have this try. You know, we were talking before about how Rox once looked at my face and said it needed some liquid nitrogen to get rid of something. So we actually did it right in my office with all my students watching. So actually, I have this seriously pain in the back. I've actually been to Mass General about 4 times with all these like pain injections, but they haven't really worked. So I think I'll have to try this.
I hope we will help you, Bob. It's true. Actually, we treated your actinic keratosis, and
I didn't know the
students. His students came out, and we didn't realize that we were the show that afternoon for everybody. But I'm also I'll mention a second thing. Neurofibromatosis type 1 is the most common genetic human disease, and as a dermatologist, we see these kids that are born looking pretty normal, who over time progressively have hundreds or thousands of skin tumors that become grossly disfigured. That's a genetic disorder, the most common because the gene is the size of a barn door. I mean, it's a 350 kilobase gene, and they have loss of heterozygosity. So we basically don't treat them for years. We've seen these people, they're devastated, and we ignore them until they're so burdened with tumors that you take them to the OR and cut them off. So a couple of years ago, we started a pilot clinical trial just seeing whether something better would work. And it turns out that injection of an already FDA-approved drug, deoxycholate, is just a mild surfactant, makes these tumors melt away. And for me, it's a dilemma right now. I know the expertise that's in this room, that my lab group has figured out how to treat this with an old drug. And I have never in my life taken an old drug and tried to make it new again. I have no personal experience of how to do a generic or something. So anyway, but I'm very excited about it because what makes me tick is in fact helping people, and we're going to help a lot of people. This is about 1 in every 2,500 people, so there's millions of them around the world. And now I'm going to flip it over to you. What's hot in the Langer lab?
Sure. Well, thanks. So I'll actually mention a couple papers that are going to come out. Actually, and they have some origins actually at Mass General. But one of so the 2 areas that we do the most in are the area of drug delivery systems and tissue engineering. But so to pick drug delivery, Vikesh Schwan, he was a graduate student, worked with Rakesh Jain, who's a colleague and good friend of mine, and he has been a postdoc with me and also with Phil Sharp. So people probably are very familiar with gene editing, but one of the problems with gene editing is you can make errors, and they're called indels. But Vikesh has figured out a way of engineering enzymes so that he can get 60-fold less errors, and in some cases, 0. And that's actually going to be coming out in, I think, well, it's coming out in Nature either this week or next week. And it's really beautiful work. He's done an amazing job. And a second one, which I'm excited about, this is more in the tissue engineering one, Li Wei-Sai, who's head of the Picower Institute at MIT, called me up about 4 or 5 years ago. She said, well, can we write a grant together on how you could actually make a personalized brain in vitro, like on a chip? So we actually got that grant from NIH, and I hired this woman, Alice Stanton, who was a graduate student with one of my postdocs who was a professor at Stanford. And she came and she's done an unbelievable job. She's actually, so we could take pretty much anybody's regular cells, convert them into what's called an iPS cell, and then convert them into the 6 different brain cell types. And she's also figured out a matrix that you can put them on that reorganizes and actually makes literally a brain on a chip that's got tight junctions, that has a blood-brain barrier, and so forth. And so that's going to be coming out, my guess is in the next month in proceedings of the National Academy of Sciences. But what I was also going to say, and people here may know this, probably much better than I in some ways, but Mass General, I guess, they have a great neurology group. In fact, one of the people who was head of neurology was Merit Kudowitz, I was her pre-med advisor many, many years ago when she went to MIT. So I was over talking to her with Alice, and I guess Mass General has a new neurology institute that they've set up, and the first person they hired was Alice to be assistant professor there, and I think she's going to do an unbelievable job. So those are two things that are coming out soon that I think will be really pretty revolutionary. But I suppose one of the other things that we've spent just a tremendous effort in our lab on is really working with the Gates Foundation. They're by far our biggest funder, to create new delivery systems and other things for the developing world. Vaccines that you could just take once, and last, and you'd never need another one because people often don't come back. Pills that you could swallow that might last for the entire course of treatment, even if it's a month or longer. New ways of giving nutrition. And things like that. So they've been incredibly helpful, and we have quite a few graduate students and postdocs working on those kinds of things, and some have actually led to companies, and others are leading to different kinds of nonprofits that we've used, that we're trying to introduce some of these things into Africa and so forth.
It's interesting how if you attack a health problem outside the U.S., you have to do it differently. And somehow you have got the bug. You got the bug. I wanted to ask you, how did you? I mean, look, you're a PhD, you're an institute professor, all this stuff, but you have actually saved more lives than most of the physicians I know, and you've done it through technology and through your smarts. Is that what makes you tick, Bob? Are you in the? I mean, it's interesting. Some people go for the technology. Some people love basic science. You seem to have some formula of all of this coming together. You're one of the most prolific people I've ever met, and I'm going to ask you what makes you tick.
Yeah. Well, I've always gotten an enormous amount of satisfaction out of. I mean, it's going to sound almost trite, but helping people initially by teaching. And but I kept searching. I kept searching for ways that I could do that. And I probably shouldn't have gone into chemical engineering for some reasons. But
well, don't tell me that, because you're one of my heroes.
I was going to close the loop on that. but I mean, the reason I said that is, when I graduated from MIT in 1974, pretty much all my friends went to work for oil companies. So I thought I'd do that. That's mostly what chemical engineers did. And I just, when I went there, they keep talking about how you can increase the yield of this chemical or the petrochemical or that petrochemical by a tiny percentage. And so I really, that didn't excite me. I got a lot of job offers from them. Anybody could have. It wasn't, you didn't have to be that good. But I kept looking for a way that I could do something. First in education, I tried to a lot. I'd helped start a school for low-income kids in Cambridge back in the early 70s when I was supposed to be doing my thesis. And I loved creating new curricula and things like that. I tried to get teaching jobs and nobody would hire me or even write me back. And then I had this idea about medicine. So I wrote to a lot of hospitals and medical schools, and they didn't write me back either. But then one day I walked in the lab, and one of the people said, Bob, you should write to Dr. Judah Folkman, who actually trained at Mass General. He said, you should write to Dr. Folkman. He said, sometimes he hires very unusual people. And
Worked out pretty well.
yeah, but that changed my life because I was the only engineer in Children's Hospital, and it was almost like, and you would have been, it's like being a kid in the candy store, which you're a good example of. And so I just learned so much about that, and I could see that chemical engineering, that's what I meant by closing the loop, by thinking differently, that, maybe we could come up with some things that would help people, and I've got a lot of satisfaction out of that. I mean, some of it is really trying to do basic science, but I really want to do science that can make a difference. And that also got me to starting companies because I thought naively, and I was very naive, that if you just wrote a scientific paper, lots of people would use it, which is absolutely not true.
It's absolutely not true.
Yeah.
But it's amazing how many academics don't know that.
Yeah.
And you also have a real love of actually going the whole distance. So if you do science in a lab and you discover things and you engineer something new, pitched at a problem, for many people it's over when they publish the Nature paper. For you, that's just not even the beginning. I wanted you to talk a little bit about. So you're an amazing guy. This is the Bob Langer fan club, okay? You do science, you teach, you start companies, you make sure that those companies succeed. And Bob and I have done some companies together, and they haven't all succeeded.
No, they don't.
Right, they don't. But you learn along the way sort of what makes for success. You want to talk about that for a minute?
Yeah.
How can you pick a good problem and get it all the way through to where you actually help humanity?
Yeah, well, it's a great question, and we have done it several times, and I want to get your thoughts on that as well in a second. But my feeling is it's first of all, you're going to fail an awful lot of times. Also, what I think is if you're not your own champion on most of these things, nobody else is going to do it. I mean, you really have to try to do it yourself. But in the end, it's always a team effort. I think somebody like one of us, and I'm sure many of you, you could come up with the idea and you can, do some work on it, but you need all kinds of great people. You need, really good business people. You need, you need everything. I mean, it's really, and how you do it, I think when I really look back, I'd love to say that it was, if a company succeeded, it was because of me, or failed or whatever, but it hasn't been.
But it doesn't fail because of you, but just succeeds because of you.
Well, I don't think it does either one. But I've always found like that having a great CEO, that makes all the difference. And that person, what does that person have to do? Well, they have to raise funds. They have to be able to, really have a vision. They have to be able to hire great people. And you need great people across the board. You need a great business officer, medical officer, manufacturing later on. You need all those things. How do you think about it? I mean, you've had a number of companies we've done together. I mean, of course, one of them, we got Jennifer Aniston to help us.
Yes, that was great. Yeah, that's a perk.
But I'd love to hear more broadly. I won't tell you about.
By the way,
Rock.
she has the most beautiful blue eyes, and they're real. Okay.
And I won't tell anybody about Rox fixing or her inspecting her nose, but which she asked him to.
For me, it's because I'm a practicing physician, and we, as physicians, we have a front row seat to the drama of human life. For me, it's about picking a good problem. A problem actually worth solving, and not worrying too much about what you are. So my training at MIT long ago was physics and then biology, but I don't think of myself as either a physicist or a biologist. It's about solving the problem, whatever it takes. And I agree with what you were saying too, that like when things fail, there's so many ways that things can fail if the people aren't right, the leadership. But at its root, picking the problem is really important. And I think some of the biotech, even in Boston, the sophisticated mecca for biotechnology here, Some companies fail because they never got the problem right to begin with. So that conferences like this, it's the value of having clinical people and business people and scientific people in the same kind of room. This reminds me of working with Warren Zapol. Warren was the chief of anesthesiology at MGH and in fact the Harvard Medical School for many years, and the inventor of inhaled nitric oxide. My practice in dermatology is children, so I used to take kids to the OR. I'm probably the only dermatologist they actually let into the OR, okay, at Mass General. We give these kids with very complex things. And anyway, Warren and I became friends, and then we taught a course at MIT for 8 years that was exactly about this problem. What is it that begets success or failure? This was the biomedical enterprise, program at MIT, which graduated some really good people and who are in fact really changing the world now. I bring up Warren in part because he wrote this book, and this is a shameless plug here. On your table, there's cards with a QR code on them, and I encourage you to do this. Warren was an amazing guy. He was curious about, respiratory physiology, and he would go to Antarctica, capture seals, and instrument them and make them go for a long dive. How is it that a seal made of flesh and blood, just like us, not that much bigger, can take 6 breaths and swim for 45 minutes, right? We would all be brain dead, and he figured that out. He was another one, Bob, who I think you have to have 3 things right. You have to have the medical part right. You have to have the entrepreneurism, the spirit to go off to Antarctica and do weird things, which is what this book about. This is called Dr. Adventure, and it is exactly what Warren was. But then you have to get the business part correct, and you have all of those.
Oh, I don't really. To me, like you say, it's a team effort. I think you also have to know what you aren't good at, and I mean, I think I'm for an academic, I'm okay, but really the people that you have to have. I mean, they're working all the time and hustling, and and it's a hard job. But then I know when I hear about CEOs getting too much money, I think whatever they get, if they're really good, they deserve it. So I think it's very important to realize your limitations for everybody. Along those lines, I was going to say, one of the things that both of us, I think, have been proud of, and I was going to ask you first, is the people that learn from you. The people you've mentored, and I've known quite a few people that have worked with you, and they always come back saying about what a great experience it's been. So what is the thing that you do? What has been your magic in terms of that?
Oh, I don't have an answer. This is unrehearsed,
Well, of course, but yeah.
But I think part of it, so as an educator, we were both very much into that, and you have to meet your students at whatever level they're at. So there's such a huge range of intellectual diversity. It's a great question, Bob, because you take somebody into the lab or training them clinically, and you expect them to do something, and you quickly figure out this is like not the right person for this project. But I think a good mentor is more about the person than the project, and so you figure it out. You help them find their better way. And I've enjoyed working with your students as well, very much. And we've shared a couple of students even recently. It's been kind of fun. So to me, I also humbly am a student. I have a lot to learn. And so I think you have the same way. You just, the people you train understand that it never ends. I told the fellows that getting into the fellowship is really hard, but getting out is impossible.
That's great. Well, I think that's true. And when you have these students, I mean, some of your students have helped, run the companies you've done and are trainees. How do you know which ones are good, or which ones do you think? Are there any criteria that you use to think about who's gonna?
The way I think of it is it's pretty Darwinian.
It's okay.
But the people find their niches, and I try to help them do that, and know when to get out of the way. I mean, how do you know? There's something in your lab that you think is great. How do you know when it's ready to go out and be licensed and start a company? It's the same way with the people, right? And it's such fun. I know you're a father and a grandfather, so am I. And I think these projects and the people we train are very much like a family.
Sure.
Right, you don't know. And the worst years are the teenage years. You have no idea what they're doing. So I had a cousin, Fred, who was born prior to 1950 and got polio. Fred couldn't walk. It changed his whole life. I was born just 2 years later, and I was the recipient of a vaccine, the first polio vaccine, as this was raging through the country. You are one of the founders of Moderna, which saved millions of people. But the climate we're in right now is a very different one. Can I get you, just for a moment, to talk about what you think is coming in that realm?
Well, I think it's a question of what's coming when. I think Moderna, and again, I can't speak for the company, and obviously I'm very prejudiced, in many ways. But I think that what Moderna is doing is not only doing the, hopefully, the better COVID vaccines, better flu vaccines, but some of the things are really, that I think are incredibly exciting and important are the new cancer vaccines, personalized cancer vaccines. I think 3 of which are in phase 3 clinical trials. And that is one of the really revolutionary things that's going on. That being said, obviously there's people in our country who are not fans of vaccines, but I think it's going to be hard for those people to say, well, we don't want treatments for cancer, and so I expect, this next year or two, well, it's always hard to know when things will change in terms of certain people in the government. But my feeling is, and I thought this in the beginning with Moderna, is being in it for the long run. There's no question in my mind that when you look at the history of science, so many of these things in science, there's ups and downs. Sometimes those things could be due to science. Sometimes they could be due to politics and so forth. It's hard for me to see over a period of time that we won't have the best science that can save human lives. I mean, I think we will.
Well, you have saved human lives, and it's, if you think about evolution of humans, how many things had to happen to make this, right?
Sure.
By trial and error. The opportunities are huge. And I don't know enough about RNA vaccines, but the idea that you can get the body to make a protein of your own design is way beyond vaccines. So,
of course.
I just hope we don't somehow, throw the baby out with the bath here.
I don't think that will happen. There might be, with grant cuts and things like that, there may be delays in a number of areas of science and medicine, unfortunately. But I think in the long run, I have no doubt that, these things will triumph. They have, and I think they will continue to do so. There's something in engineering or chemistry, we talk about thermodynamics and kinetics. Thermodynamics is sort of where it's going to end up. Kinetics is how fast you get there. I have no doubt that the thermodynamics will be clear cut, and these things will solve many, many problems. But maybe it'll slow down a couple over the next year or two. We'll see.
We sure will.
Yeah.
Yeah. I love chatting with you, I have to say. This is a bit like getting on a red-eye flight, from California to Boston, with 300 people in a pajama party that you don't really know. And I like it. It's exciting.
We'll have to create that plane.
So Bob, can I ask you another thing about industry?
Sure.
I think academia and industry, the biomedical technology industry and healthcare, they all need each other. They literally can't exist without each other. And yet it seems like, so you're an academic, I'm an academic, we get involved with companies and do that, and then I'm a physician. You end up being one of the few PhDs running around hospitals a lot as well. Those three items, healthcare, business, innovation, and education in an academic center, kind of do a tango. What is the tango? It's a dangerous dance. I mean, have you ever watched people tango? I mean, you can get kicked in the, and I think they're different environments. And how do you do it? You are in all three environments, and your students somehow learn how to be in all three. And here comes President Trump right now. Okay. What did we say?
Well, yeah. So I think the question is, how do you be in these different environments? I don't know, to me, I mean, one of the things that I think has been great about MIT is, I mean, it's not a medical school, but it has the great fortune of being near these great hospitals like MGH and Harvard Medical School. But in terms of science and engineering, I mean, I'm prejudiced again, but it's pretty unparalleled. And in terms of industry and spinning off things, in terms of companies, I'd say it's one of the two great institutions in the world, the other probably being Stanford. And it's almost part of the culture. And I think when students come there and fellows come, I mean, we've had all kinds of great fellows from MGH and other hospitals come to the lab. I mean, that's what they want to do. They want to they want to do the research, they want to see the research make a difference. And of course, if you just, again, left it as a paper, the chances of it making a difference are just much less. And I think a lot of people just get this fever of wanting to change the world and make it better, and that's great.
And obviously they can. When I was training, it was sort of dirty to work with industry.
Yeah.
And the only good money came from NIH and a peer-reviewed grant and so forth. And that's just not the same. And maybe I'm just an old fuddy-duddy, but I think Gen Z is going to be doing this really differently. So I'm just trying to get you to maybe take a shot at what the future looks like. In my version of the perfect future, those three things would really be on the same page. Somehow, academia, industry, and medicine.
Well, I certainly think things are moving in that direction. I don't know whether there'll be an asymptote, before you get to everything. But I do think, I mean, one point you made, which is really true, is when I look back to the 70s, it was kind of considered almost a dirty thing to work, if you were in medicine, or even if you were in biology, to think about being involved in a company. I mean, there are a couple people that would do it, but most people did not. And a lot of people looked down on it for a long time. I mean, I certainly found that, just with my own career and watching, a lot of people just really felt it was a bad thing, and I watched that sometimes in tenure cases and things like that for a long time. I think that has, as you pointed out, really changed. Not perfectly. Perfectly would be, there wouldn't be any of that looking down upon it, but I think more and more people are changing. And partly tied to that, again, if you go back to the 70s, if somebody looks at an educational institution, it was very almost isolated, right? If you went to a college, there'd be a building for English, a building for math, a building for chemical engineering. Today, lots of times we have that mixed, like what we call convergence. And like in the building I'm in at MIT, we have 7 different engineering disciplines. We've got MDs, we've got biologists. I think that really fosters the kind of thing that you said. And also what fosters it is they actually made a point when Tyler Jacks was like head of the building and Phil Sharp was very involved. They said, starting companies, that's a really good thing because we want to see the things we're doing in cancer and other areas get out to the world. So so they celebrate. I think that's very important when the institution celebrates those kinds of things. And I think that all moves in the direction that you're saying. But there may be, there's always things that come up with conflicts of interest or other kinds of things that people put up there.
And I think we have an obligation to talk openly about the conflicts and, in fact, teach people how to deal with them. I think the old days there was a lack of trust, between people in industry, and it used to be a one-way street. You go off to some company, you never came back to academia, and now it's not that way, which is an improvement. I think we're on the road to what I would say is a really synergistic, connection between them. I'd love to see more industry teaching, right? It's interesting how you can sort of cross over between medicine industry and academia and sort of play the other role, because ultimately we all went to school, right? So we can all do that. But anyway, I'm just tossing it out there and hoping that there's some resonance with this, because I think there's a transition, a very strong transition in that way. All across the country, people are becoming more entrepreneurial. I don't know a single department that is not doing something medical, right? Certainly at MIT. It's everywhere. And so we have an opportunity, I think, to sort of get it right.
I think that's great. I think we're both prejudiced in terms of that direction, but I think that direction has changed a lot of lives and made a lot of lives better. So I think that's been a really good thing.
So if you look 5 years out, just take where do you think you're going to be in 5 years, Bob?
At 77, I hope I'm going to be alive. I worry about that. I see.
I'm 70. I will be 75 next month. So we're not so far behind. Okay.
Yeah, but I feel like I hope that the biggest thing is your health. I've been lucky so far. I don't know. On the one hand, my dad had a heart attack at 61. My mom lived to 100. You just don't know. I'm hoping I have her genes.
Well, I'd say you chose your mother quite well.
Yeah, well, I think I did too, but I think it's always scary, right? You look in the newspaper and you see like Robert Redford died yesterday and David Baltimore a week ago.
Yeah.
They're not that much older, and so you worry, and you see that I see lots of people a lot younger. So it's great that there's great hospitals like Mass General and others that are around to help do good things.
Well, on that note, there's lifespan and then there's health span.
Yes.
And I think there's probably some resonances in this room that the health span is what's actually worth working on, both from a sort of societal and economic point of view. I think if we had a pill that made people live longer just to live longer, it would destroy, if not our society, the planet itself.
Yeah.
But I don't know. I mean, this is unfair, Bob. If I ask myself these same questions, I get scared. What does a guy like you do to retire? And maybe not retiring is a perfectly good answer.
Yeah. Well, I think that's right. I mean, again, I think even people I know that got older, as long as they're mentally able, they're going to keep doing something. I mean, you do an incredible amount, and I think that's a great...
I don't want to stop.
Yeah. Well,
I'm addicted, by the way. It's so appropriate to have this meeting, Chris, in a place where there's gambling. I mean, look at all the entrepreneurs here. We're addicted to this, and in every way. So it's kind of fun.
Good line, yeah.
Yeah, it is addictive, isn't it, what we do?
Well, I think if you love, I've never viewed what I did as work. I kind of just view it as doing what I want to do, and it's nice if you get paid for it. But it's, but I just always felt that, whether it was starting a school or doing research or starting companies. They're all things that you feel good about, and I feel like very, very lucky. I imagine you feel, how do you feel from it?
I feel totally lucky. I go around, I love, one of my true loves is going around the world taking care of other people's children.
Yeah.
With stuff that we've invented and have I'm shameless, so I call some CEO of a laser medical company and say, you really should donate this to Pakistan, right? They say, okay.
And you're doing a lot with
It's fun for
and
me.
you're doing a lot with Vietnam. And
I go to Vietnam every year. It was my generation, your generation, that killed many Vietnamese, and I still feel a sort of sense of payback, actually. It's a personal feeling. And it's a lot of fun, and oh, by the way, you go around the world and you see things that we don't have problems with. In Vietnam, they make radioactive phosphorus, P32, with these old French cyclotrons, and they paint it on baby girls as a misguided treatment for infantile hemangioma, the most common tumor of babies, right? And so we go over there and we see these kids with just horrible radiation poisoning, right? And what that made me do was not only try to stop the practice, which we've largely succeeded in doing over the last decade, but made me realize how poorly we take care of tissue that has been exposed to ionizing radiation. So you look at women with breast cancer and radiation oncology, it's great that you don't die of cancer, but radiation is the gift that keeps giving. So we've started some clinical trials to try to mitigate it. It's fun. It's like we were saying, it's addictive, problem solving, and it feels good. So, but before you retire, I want to take a biopsy so we can clone you. Because this guy is really unique, folks. He's just a one in a kind. Yeah.
Well, it's absolutely.
And I think we're allowed to take questions. Can we do that? Do you want to do that now?
Sure.
Or do you want to keep going? We can keep going.
Well,
all night.
Paul, whatever you think.
A few questions. I know he's got something, but let's keep going. Here we go.
So this was just to let you know you can ask questions, and Bob and I will.
We'll do our best.
So it would be 2025 if we didn't mention AI, and so I'd love to hear your guys' thoughts of AI in the context of medical innovation, but also research innovation. I think a lot of us assume that people are jumping the gun a little too quickly, but there is a lot of potential and opportunity there.
Do you want me to start?
Pick it up.
Yeah. Well, I think what you're saying is right. For a couple of things. First of all, I think sometimes I think people think AI just happened in the last year or two, or ever since ChatGPT came out. Actually AI has been around 80 years, and I think what's happened because ChatGPT is such a great demonstration for people. All of a sudden, there's a thinking that it can change the world. But it's been an evolution. I mean, we've actually used machine learning, if you want to call it that. Even one company we started years ago with Mike Seema and Nick Alakatos, this was in 1999. One of the big problems with drugs is about 50% of them aren't soluble enough. And so we actually did thousands of experiments, which you could do if you were doing something as simple as measuring solubility, where we'd add different excipients. Rather than just one, we might add 5, and we'd keep track of it, and we got lots and lots of data. And then we could iterate, and then make it, the next iteration we made a couple that were more soluble. We saw what enabled that to happen. Then we were able to make it more and more soluble. We were actually able to increase solubility in some cases, 50 or 100-fold. And because of that, that led to new drugs. Johnson & Johnson actually acquired the company for, after just a couple of years for 25x, of what the investors put in. But that was all just because of machine learning then, and that was way before ChatGPT. I think that, and there's lots of people who use it. Right now it's being used, Regina Bargeli's been looking at it as a way of better determining whether somebody has breast cancer or not. You can use it for imaging. We're certainly looking at it in our lab with Dan Anderson for designing better lipid nanoparticles, that could even be more shelf stable and things like that, or target to particular cells. But so many people are using it for all kinds of things. I think, of course, a lot of people are worried that it may be dangerous. Actually, Reid Hoffman, who started LinkedIn, he just sent me this book I should have, it's funny, about AI. I didn't really pay much attention to it in the beginning. Then I looked at the back cover, and it had a picture of me on it. And then he's got quotes about me from Shakespeare, Tesla, and I forget who else, but
This is
somebody.
very dangerous. Yeah.
Well, actually, but he actually thought, it was actually very, very thoughtful when you read the book. Then I actually looked at the foreword, which apparently I also wrote. Again, I did nothing, and I even wrote a poem.
But that was ChatGPT that wrote that, right?
I assume he's an investor in OpenAI. But then, then there was a lot of pictures of me and stuff. But then there was really his book talking about, I mean, you couldn't tell where it started and stopped on this. But what was amazing about the book is, to your point, he said, well, there's actually 4 groups of people. I'll see if I can get this right. Doomers, gloomers, zoomers, and boomers. What he means by that is the first 2, they are very afraid that that's going to wreck the world. He said, well, he's a boomer because he feels it's going to do a lot of good, and I'll get to that in just a second. But you have to be careful about it. And then the zoomers will use it for anything. So what he did is he went back through history and looked at all different kinds of things, like when cars came. People said this is going to be, a lot of people said they'll be awful, we'll have, all kinds of pollution. But he actually said, well, you had horses before and you had more pollution. And same thing with, DNA, people were concerned about, that. And example after example, he showed that, sure, each time these things came, it caused some problems, and people hopefully figured them out. But it also caused some advances, and he expects that'll happen here. That would just be my 2 cents.
I'll put a medical perspective on it. It's interesting, I can't remember where it was published, but there was a comparison done that the generative language AI is good enough now that you don't know you're not talking to a human, right? So they took people and had a virtual psychiatric visit for patients talking to an AI system versus an actual psychiatrist. And then after that, they had the patients rate the interaction. It was quite interesting that how is it that you think the AI system beat the human? What is the thing that because the patients felt better, there's a catharsis, just talking about, I mean, I'm feeling it right now, Bob. It was in empathy that the AI system was far better. And there's a reason for that. It's not in a hurry. It's quite capable of saying, yeah, tell me more, and meaning it, right? Or it doesn't mean anything, but it says it with a, The human, on the other hand, and this is a huge problem in medicine. It's a problem in MGB right now. You try to find a primary care appointment in less than 6 months. I mean, honestly, folks, we have a big problem. And I would answer your question by saying I'm very excited about the role of AI when used properly. And it's just like any other new technology. Einstein came up with E equals MC squared, and some people made, bombs. It was not a great decision. By the way, if you mix Einstein with the best parts of Woody Allen, you get Bob Langer.
Wow.
Other questions? That's a good question. Yes.
So thank you very much for allowing us to join your rich conversation. So given all the years, and you've seen a lot of ups and downs in academics and science and research, what advice do you have for us for how we can rebuild trust back into science? We know that the Edelman Trust Barometer says 61% of the US adults believe that business, media, NGOs, institutions actively discourage me from getting quality health care. What are we going to do to rebuild that trust in science?
That is a very good question. I've spent some time thinking about that. I have to say that the trust, why does the trust exist to begin with? If you go back far enough in medicine, believe it or not, people trusted shamans and medicine men that shook rattles and made incantations because that's all they had. And now along comes technology, the vaccinations for smallpox saved who knows how many lives. And that did not go unnoticed because the people alive then knew what those infectious diseases would do to you. If you walk through and this is one of my favorite things to do, you walk through the little graveyards that are peppered all over New England. There are a huge number of nameless children with a little stone, right? And there are large numbers of young adults who died, mostly women in childbirth and men in farming accidents and wars. And if you know that reality, then trust comes because you see the benefit of the science. I think what the era we're living in now is one where the lack of trust is this sort of option, right? I hate to say it, but I mean, if there's this kind of Darwinian reality that we will never ever escape. If you don't vaccinate your children and they do get polio or measles or the next pandemic, your trust factor will change, right? And it comes from experience. I think another part of the question is, though, how do you educate in a way I think right now our society is so polarized. Like, I don't want to come across as a vaxxer against anti-vaxxers. No, you have to listen to the other side of the aisle, so to speak, and really listen to them. And I feel that takes effort. It's like going around the world taking care of other people's children. There's huge differences and barriers to that. But if people know that you're there only to take care of their children, then all of the stuff about religion, politics, et cetera, goes away. We need that kind of substrate, like caring. There's not a parent, no matter what your love or hatred for science is, that doesn't care about their children. So you find points of common human interest and start somehow there. I don't know. I'm a terrible idealist. Bob, what would you say about this question?
I think it's a great question. It's very complicated, and particularly at the age of misinformation, which I think happens. I think you gave a very good answer. I guess I just wish that the press and the media, could do a better job, But unfortunately, what happens is a lot of times it's things that get sensationalized and trying to stir things up. So, but I don't think you can change that very easily. But I think hopefully you get people in the media that people will. In addition to everything you said, I think all the things you said are right. I think that the media can play a big role, both ways.
The opposite side of the coin is blind trust in technology and science, which is equally wrong.
I agree.
So there are things we all need to listen to. It's a great question. I hope you solve that problem. When you do, will you make sure you tell me?
Let us know.
Hi, this is a question for both of you guys, Bob and Rox. It's for my benefit, but I'm gonna imagine it's for all the young people. In this era of where we ask for funding that's really based on innovation and significance, only two criteria. How do you choose problems that are not iteratively solving anything, but are really transformative?
Well, I think it depends on, different things come to you in different ways. For me, in the beginning, I felt like what Judah Folkman was talking about with blood vessels, I felt that was, and what I didn't know very much about medicine, but I felt that could be transformative. I thought when we did the work on nanoparticles, most of the people told me that would be an impossible thing to do, but I thought if it could be done, there'd be a lot of different molecules that might someday make a difference. I would have been wrong about which ones I thought at the time would have been most useful, but I wouldn't have been wrong about the fact that if there are thousands of things you could put in it, it could be. When Jay Vacanti and I talked, I remember he came to me seeing one day, he was also at Mass General for a long time, and he said that could we come up with a way to make new tissues and organs? And we thought of some ways to do it. And I thought, those things, even though you don't know exactly where it's going to go, you can sort of feel like that they could make a big deal. I've had Bill Gates come to see me about a number of things, and he's got some pretty good ideas too. But a lot depends on having that kind of filter, and you can't be sure you're going to be right. I mean, but makes you think, well, this might be worth a try.
I guess I would. I have maybe as a physician, a more personal answer to what problems are worth solving. I think it's perfectly legitimate to be. Like if you happen to be the carrier of a disease gene, it's perfectly legitimate to go all out and go after it, even if it's an orphan disease. I mean, it's not so much the numbers, it's the severity of the problem. I have kids, and I have experienced where, you take them to the pediatrician, and as soon as they see a needle and a syringe to do the blood tests, the kids scream bloody murder and can't stand it, right? So that experience, literally, as a father, I challenged one of our scientists at the Wellman Center, Charles Lynn, can you do a white blood cell count without a needle? Can you do it totally non-invasively? And darn if he didn't do it. And he gave a talk, or will give a talk, tomorrow. Well, it's a shameless plug for go to his talk. He basically figured out how to use your own capillaries as a flow cytometer, make a very inexpensive optical system that will then count the cells as they go by. Use AI to identify which lymphocytes are there, granulocyte series or lymphocyte series, and get you a white count in real time. And that project, I had nothing to do with the technology, but I said, can you do this? I'm tired of going to the pediatrician with my kids. Another thing, one of my favorite questions to ask people for years in the hospital realm is, if you had a magic wand, what would it do? All right, that's a very revealing question, because you have to ask it with great sincerity. Magic wands can do anything. And what you're really saying is, in your life as a physician, whatever it is, you're an orthopedic surgeon or a cancer person, whatever, what is it that really frustrates you? You really wish you had a magic wand. And we started I started a little program in dermatology at MGH, which we called the Magic Wand Program, because I literally went to the lab and used a 3D printer to make magic wands, passed them out to the clinicians in our department, and at the end of grand rounds one day, I said, look, let's do an uncontrolled experiment. You grab if you feel like it, grab a magic wand, and when you're seeing patients for the next month, when you find something you wish you had a magic wand, you get it out, and you write the problem down. I'll see you in a month. What happened was really interesting, that it was on a weekday after clinic, got the people that had used their magic wands together. They wouldn't go home. We started this, these are busy clinicians who hadn't had dinner, talking excitedly about problems that they faced that they really, really were passionate about. And out of that have come 3 or 4 young faculty doing NIH funding. They were, instead of leaving and going into private practice, they became academic problem solvers. A couple of startup companies and such that rolled out of that. And we took it from dermatology to out of MGH and started this Magic Wand program. Raised a couple $1 million philanthropically that then pushed that through. And now in Derm, you can do a virtual magic wand training. And the chairman and the people in departments love it. it somehow is the antidote. See, clinicians get burned out. We are expected to see patients really rapidly. Before COVID blew into town, I was expected to see a patient every 7.5 minutes. That's not fair, right? But if you engage the clinicians in problem solving, I mean, that's why they're at Harvard or wherever, right? So anyway, I'm sort of passionate about that, so I spent too much time talking about it. But it is an answer to your question, because I think there's a personal connection to the problems that are worth solving. And you can then figure out among those, like, which ones are actually, we have some creativity and stuff. You do the brainstorming, and it's fun, yeah. Great question. Anybody else? I'm just kind of like, I feel like I'm tossing Hail Marys here. We got one in the back, and then we'll quit. Oh. Just yell.
We'll repeat it. Maybe why don't you come up, and if you just walk up, your voice will, yeah, and then we'll repeat it.
And then we'll be done, I think. This is the last hurrah.
So if you're still here, whether you work for MG or you're in, but for the young researchers out there, life gets expensive. This is more of a personal question. And you did mention back in the days they wanted to work at the NIH and SF grants, and instead of going to the industry. What's your advice to the younger folks at this point? Folks who are just out of their PhDs, MDs, the young engineers out there who really want to do something impactful, seek answers to very interesting questions, but life is very expensive.
So
They have bills to pay.
the question is, what's your advice to young people who, despite all the challenges, really want to have an impact? And I'm going to let Bob answer the question.
Well, I personally think that you do a lot of job interviews, not just to get the job, but to learn something. It's funny, when I did the oil company thing for Chemical, I learned so much, about what I didn't want to do. And I talked to people about how they made their decisions. Why did they work at the company? What did they like? Then, like I say, I tried to do things for universities and hospitals. I think that doing a lot of interviews and talking to a lot of people that are older than you and that have gone through the very questions you just asked, I think you'll learn a lot. So my wife actually one time said to me, that it's like a full-term course trying to find a job. A semester. But I just think and I've always tried to tell my students, if they get a job, the first job they get, and they say, I want to take this, it's fantastic. I said, you should still keep looking, because it's almost a gift to have that time of your life where you can really think about the very question you asked, think about what you like and what you don't like, who might hire you, who might not. So I just think I just talk to a lot of people and do a lot of interviews when the time comes. That would just be my 2 cents.
So his answer is network, and Bob's the only guy. This guy has an incredible network. But I agree with him. You have a gift of time, and you can sort of figure out your niche. Good luck. I think we're at the end of our venue, and I just want to thank everyone here for what you do.
And I second that. Thank you for having us.